Welcome. In this lecture, we're going to go through the second case. So we're going to be looking at this case in this lecture. Okay. So what's happening in this case, which is that as we input, sometimes it's a little hard to write clearly on here. So as we input, so we're looking at, and we're using the convention, we're dropping that orange stands for degree, and we're using, so if we're looking at larger and larger positive x values, right? This is the limit, right? This is the limit as x goes to infinity, okay? Or, right, in this circumstance, we're looking at larger and larger minus x values, okay? In either of those circumstances, we're going to get that p of x over q of x gets really big positive. So this gets really big positive. Let's just do this in green. Because these are outputs, and so I think that it kind of helps out to actually do this in green. Okay, so this is going to get, this gets really big positive. So really big positive or really big negative. So, or really big negative. Okay, so i.e., what am I talking about there? So what am I saying in what I wrote there? So i.e., the limit as, so this is where we're going, x goes to infinity, right? So that corresponds to larger and larger x values. So this limit of this p of x over q of x is going to equal, so I'm going to get out plus or minus infinity, okay? And I have this limit as x goes to minus infinity of, again, this p of x over q of x gets out plus or minus infinity. We talked a little bit about that before, that means that you either get out positive infinity or you get out negative infinity. That's kind of what I mean by that notation there. And how do we actually kind of figure out what those are? Okay, so if I'm looking at, right, I'm worried about these plus or minus signs, that what I want to do is I want to plug in, okay, so how do I sort these out? And what I want to do is I want to plug in really big x values. So plug in really big x values, or just look at the graph. See, or I just want to look at the graph, right, to figure out the sign. And I'm going to do that in green because it's kind of the sign of the outputs. Okay, so that's how I would kind of handle that. So we want to look at an example, and we're going to kind of draw this over here. And our example is going to be, so here we're going to look at an example. And my function is f of x is going to equal x cubed plus 1, so this is x cubed plus 1, divided by, I don't know how clear that is, that's a 3. It's kind of hard. Okay, x cubed plus 1, I'm still not happy that I'm not convinced that you can read that, so let me try one more time. Okay. We're going to make this so that you can read it. So let's make this x cubed. I'm hoping you could, oh, that's good. Okay, x cubed plus 1 divided by 1 minus x squared. And looking at our degrees, right, we can see that the degree of this one is going to equal 3. I'm going to actually not do that in orange. I'm going to do the degree equals 3, right, because that's the highest power there. The degree of that is 0, degree of that 0, the degree of this is 2. Okay, so we are indeed in this case. Okay, so we are in case 2. Okay, so we're in case 2. Okay, because I had the degree of the top was bigger than the degree of the bottom, just like here, the degree of the top is bigger than the degree of the bottom. Great. Now I'm just going to draw this. So I have both my axes in yellow. So this is like my x-axis and my y-axis. Okay, and then this picture is going to kind of look like, it goes down here, and then it goes up, 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 right? So this is going to go off to infinity here. And then this is going to go something like this. So you can kind of even see, just looking at it, that I'm going off towards minus infinity as I go there, right? Okay, and we go. So, and this is what we're looking at. So this is the positive infinity direction, right? This is like x is going towards infinity here. As I go back here, x is going towards negative infinity. But our graph is, this is the graph of, right, this is my graph, equals y equals f of x equals x cubed plus 1 divided by 1 minus x squared. So that's what I'm graphing here. And if you look at this, so what's happening here is my x goes to minus infinity, I shoot up. So what does that tell me here? That tells me that the limit as x goes to minus infinity, right, of this p of x over q of x, let's just write it as p of x divided by q of x. Well, it's going up infinitely far, so this is, I'm in an infinity circumstance. And looking up over there, I'm going infinitely far down, right? So instead, what I have going on here, I'm going to move this a little bit to give myself a little bit of room. So let's put that on the bottom. So I have x is going to infinity here, because I'm going in the positive, like I'm going in the right, like I'm going rightward. And so I have the limit as, and then just like this says, I'm taking the limit as x goes to infinity of p of x over q of x, and I'm seeing it dip down infinitely, so that's going to be minus infinity. Right, and I got that because as I went infinitely far right, I'm going infinitely far down, right? So this is a circumstance where the degree on the top is bigger, so it kind of dominates. And you can look at, I mean, there's multiple ways to figure this out. You can also look at the sign of the leading coefficients. Or you can look at the graph or plug in really big numbers to figure out if it's actually going infinitely far up or infinitely far down. In this particular circumstance, as I put in really big negative values, I went infinitely far up, so I got a limit of infinity. As I put in really big positive values, I went infinitely far down, so I got a limit of minus infinity. Okay, so it's going to be plus or minus infinity. The tricky part is just figuring out which. Okay, so I hope that made some sense, and I will see you in the next lecture.